away with Vishal Puri, who's the VP of Data and Insights Engineering for Tiger Analytics, one of our sponsors. Again, we thank you all very much for making this possible because we couldn't do it without you. Vishal's talk today is going to be looking at that little leap between data and knowledge. It's quite a distance. Many people think, that's just 2 levels, right? I should be able to get there pretty easy. He's got over 20 years of working in these areas, doing large data transformations around this. And he's going to talk to us about deep learning, large language models, how all that fits in and can become an adjunct to the already existing practices that you guys have been working on. So Vishal.
Thank you. Louder, guys. All right. I'm going to. This is really not a talk about painting what's going to happen 5 years from now. Hopefully not. Right. There are imperatives that we see in the industry that can be handled today, and we'll try to paint what we see as challenges in today's data infrastructures, today's data foundations, the journeys that are being taken, and where you can go just in the near future. What can you do to improve the things that you need to anyways? It's just taking advantage of new technologies that are there, new approaches that are there. Who do I point this to? Yeah. So just a little bit about Tiger. I'll quickly go over who we are. We are one of the fastest growing niche provider of data science, data engineering services. That's all that we do: data science, data, ML engineering. There's nothing outside of that spectrum that we do. Focus completely on that. We largely consist of practitioners in data science, data engineering, application engineering, largely to do with ML engineering. We are a global delivery organization, and you can see a little bit about what our capabilities are. We tend to, whatever we do, we tend to codify, we tend to create accelerators. That's just being doers. That's what we do. Bring as much acceleration in what we do to the table as possible, so that you're not starting from scratch. Right? So we focus in the area of ML engineering, data engineering, AI, data science, and making data useful. Right? What do we see? I mean, there are 2 key related strategies that everybody is following. In the data and AI age is there to stay. Enabling data-driven culture. There are about 99% of firms that have been interviewed, surveyed, which say they have made investments. These investments are only increasing in terms of enabling a data-driven culture. Right? There are 85% of CEOs say that AI is a strategic initiative, and their investments in AI are only increasing. But what do they have to show for it, right? What are companies seeing as ROI really? If you look at it, there's probably about 1/4 of the companies who actually invested actually are reaping benefits, and say they have achieved the goals of being having a data-driven culture, or on the path of being data-driven culture. And so some say it is because of lack of executive sponsorship. Poor quality of data is one of the largest reasons why people say we haven't really taken off. Your users of data may not have the skills to use the tools, data, etc. That's the skill gap is consistently cited as one of the reasons that's out there. Similarly, for AI, you say similar reasons. Foundational capabilities lack. The ability to scale AI is an issue, and one of the interventions people see that what they can do to have better success with AI is achieving building feedback loops with human users of AI. The more people invest in building those feedback loops, the more return on investment that they see. So having point AI solutions, and having these one-off things that people do, that is what is not bringing, um, basically bringing the return in all the investments that you're seeing, right? Scaling AI is extremely important. And we'll talk about today how we apply AI, how we see people apply AI, and why the it'll be pretty apparent why you're not seeing the investments, right? Over the years, I'll just walk through a little bit of history so that we know where we are going, right? How we see data, business intelligence, advanced analytics has evolved, right? If you see, 1990s, 2000s, we had, data warehouses, data marts. We built data modeling was a big thing. The way to assimilate knowledge was really build these enterprise data models, data marts. A data modeler was of great importance, right? And then, and there was reporting solutions. There was SAS was ubiquitous in terms of analytics, right? And as we went along, as we moved into the 2000s, data lakes became more, with big data, it became more ubiquitous. There were columnar databases that came along. Soon, the power really went into the people who explored, experimented, innovated, and enabling those kind of people with data science skills was a big thing, and data modeling almost became an evil. Don't do data modeling. And a few years later, everybody is told, hey, you need a data catalog, by the way, because nobody really understands where the data is, doesn't know how to use the data. So you don't need a data model, but you need a catalog, right? So these became kind of part of your ecosystem of assimilating, discovering knowledge, right? And in the meanwhile, you have tools for self-service, interactive AI. There's streaming, driven by internet companies. They showed us how to do, streaming analytics, real-time analytics. Most of the Ubers and LinkedIn's of the world, they really showed how that is done at scale, and it's become pretty ubiquitous now, right? And finally, what we see today is basically everybody is moving to the cloud. There is cloud data warehouses, cloud data lakes, and more so, increasingly, what we see, everybody is moving towards synergizing towards is what is called a lake house, right? But people are also increasingly realizing, hey, data modeling isn't all that bad after all. You probably do need a data model, somewhere, that knowledge needs to persist, and a data model is a pretty good way of creating that knowledge and having it stay, right? The approaches to creating a data model may have changed, and they will change, as in people are taking a much more lighter approach to it, more middle out approach, right? And there's more of a push towards the data mesh kind of architecture, more federated architectures where domains become centers of how you model data, the extent to which you model data, right? So as long as teams who use the data are modeling the data, creating their data assets, sharing it with the rest of the organizations, it's okay, right? So we increasingly see data mesh architectures, and with more sophistication and use of cloud and number of tools, number of users increasing, the number of use cases increasing, we also see semantic layers, metric stores, feature stores coming in as well, right? And increasingly, all of this is being packaged as data products, right? So where do we really land with all of this, right? If you see today, most of our customers, if you see how their enterprise data platforms and their data assets are getting managed, this is really what we see happening, right? There's sources of data, first-party data, enterprise data, third-party data, second-party data. People bring it into a lakehouse kind of an environment in the cloud. If you have if you're standardized on that, right? They build common services, data ops services, observability services, etc., and bring it into a domain-aligned container of data, right? And there are domain-aligned data sets around supply chain, customer, around manufacturing, finance, HR, etc. Those are core domain areas. That's where there'll be teams aligned to those domains. There may be centralized teams that are bringing in data, harmonizing them, making them usable, bringing a little bit of structure, bringing more scale to the foundational efforts that have been happening over the last 10, maybe 3-4 years of populating data into the into the cloud. Now people are starting to consolidate, right, along the lines of domains. But then there are data product teams who are taking this data, curating it, and building very specific data products, right? There may be descriptive use cases around visualization, BI, what is happening, visibility kind of use cases, and there'll be predictive, prescriptive use cases which require an ML model, feature stores, and per data product there will be probably 3 or 4 different ML models. Each one of them will have its own set of features that will be modeled, right? So this is a typical way data is being organized in a data platform, right? And this is how you see the packaging of data. Now, any new kind of insight that you want to generate on this ecosystem basically means I either have to get net new data, I have to get create net new changes to my semantic layer, add something into my metric stores, create some new KPIs, create some new visualization, or go create a new ML model altogether because my existing ML model does not answer the question or the specific insight that I asked for, right? So I end up creating this deluge of ML models. Any given marketing organization will have multiple ML models, each individually developed for a very specific task, right? And this is all you can do at a fairly mature stage. If you're mature, you're here, right? After you have uncovered all the issues with data and everything, you're here. But even if you get here, the cost of doing this on a day-to-day basis, on an ongoing basis, bringing new insight, the agility, it's not, it gets underwhelming for a person who's paying for this, right? So let's take an example, right? From a customer domain, how that is set up, right? You've got digital, you've got digital customers, you've got non-digital customers, people. So let's say it's a direct-to-consumer company, right? You've got campaign data, loyalty data, customer service data. So basically behavioral data that you want to get together. You want to line it up. You want to create a unique profile for that data, if possible. If you're really lucky, if you're all aligned and have the sponsorship, you'll be able to do it in an omni-channel way. Otherwise, at least for channel-specific, profiles and channel-specific functions can be created, right? So let's say you're as an organization, you have the business sponsorship, everything, and you have a way to get all this data together. You have a chief customer officer who says, customer is a customer, let's get all this data into one single place, right? You create a unique identity, align it to profile, do segmentation across, across channels, across products, and build this nice 360 interaction view of the customer. Now, how do you go about doing this, right? Take your marketing and digital operations. You want to you want to capture customer churn. You want to identify what is my customer lifetime value. What's my demand transference if I if I move a customer from from one product to another, if I change, what kind of offers I'm creating for them, what if a customer is new, what a look-alike customer looks like, etc. Right? What kind of recommendations should I give them in a digital channel while they are browsing something, or recommendations if I want to push some marketing campaign, right? So each one of these tasks is basically a model that is being created by a team of people, and they're trying to keep up with they're trying to keep up with the market to see the accuracy is appropriate, and it's a pretty brittle ecosystem if you think about it, because ideally what you want with each of these models is they're all aligned to the same objectives, as in they have a strategic alignment with what the CEO wants, right? How they want to move their sales. Maybe they want to move more and more to the digital channel, right? So and then there's customer service. So you want to optimize your customer service and also meet the overall company strategic direction, right? What is the chance in my 10 models that I've created, they are synchronized and somehow giving me a consistent answer across these and guiding the customer in a way that is aligned, right? Probably very low. If you have all your data scientists, marketers all working together day in, day out, keeping a very tight tab on things, maybe you have a chance. Probably not, right? So there's that issue. Then there is with any kind of customer organization, you have experimentation, test and learn going on, right? A fundamental thing with any kind of digital operation is you keep testing out your product, you keep testing out how your customers are responding to it. So you build micro campaigns, you measure those campaign values, you set up experiments, you measure the experiment values, etc. Anybody can guess, what's the issue here? Well, for one, you can measure, as a test and learn capability, you can measure what you're doing, but the next experiment that I do, how am I applying those learnings? These learnings are tied somewhere in somebody's mind. They applied it once. What about the next time? Is that knowledge being assimilated in the organization to apply it the next time? Am I building on top of it? And when the market changes, how is that knowledge changing, right? That really isn't captured. Those things are lost, or require a whole lot of manual governance to make sure over a period of time you keep using that knowledge that has been gained over a period of time in a test and learn environment, right? So how do you ensure the knowledge that you'll get from test and learn initiatives and the models that you create are based off a consistent knowledge base, right? A consistent strategy, a consistent balanced scorecard, right? That is the essence of what we are talking about today, right? I'll take another example around supply chain, right? Which is one of the favorite things everybody is looking at today, and primarily because the supply chain is it's a difficult place because it has so many different channels, right? There is the plant manufacturer, there's the supplier network, there is warehousing, there is all the way until you sell the goods. There are different silos. Typically, the systems are siloed, processes are siloed, the management is siloed, and how they collect data is siloed, right? And if you are very, very lucky, there is somebody who sees these silos are not helping, especially did not help when the pandemic happened, and says, hey, we need to solve this problem, at least let's get the data together in one place, right? Once you get the data together, you realize, hey, I cannot connect the data because it's lying in different systems. I simply cannot connect, for example, if my truck left a warehouse, carried a purchase order, when it landed on a customer site, that purchase order was carried in some other system, so I can't even tie the purchase order together, right? Leave alone the product. So there are several issues that happen in connecting the data, leave alone creating predictive insights across the value chain, right? So connecting the data becomes an issue. The other thing is a lot of the insights that you're trying to bring when you connect multiple processes together are lost in the context. Context is important when you are creating insights. So, for example, if you want to know if something went wrong, in my fill rates in my customer, right, a retailer are going down as for a manufacturer, and I'm trying to find out what's going on, right? Is my plant not functioning right? Has the demand gone down? I don't know where things have gone wrong, but my data is not really telling me what I need because I have not really captured the context. I do not have standard operating procedures of my of my process. I don't treat my process as data. I do not capture the data flow as part of the data itself, right? Which is context that is extremely important when you are doing analysis of a process, right? So what I do end up with is by customer service, by my transportation, logistics, by the integrated planning operation, manufacturing operations, I have a bunch of KPIs that I track which are not connected, right? I have basically independent models that are not connected with a common balance scorecard, which brings the organization strategy together, right? So what can we really do about this, right? So let me park this for a second in terms of what we'll do as a solution. Let me take us back, in terms of how people were trying to solve these problems over the last few years, right? So how do you capture knowledge, the lack of knowledge, etc., right? This is a great picture, by the way. This is I didn't create it. It's a knowledge ladder representation. How we as humans consume knowledge, how we create knowledge and walk ourselves and educate ourselves over a period of time. You capture data, you observe data, you create assumptions, you create out of those assumptions, then you create conclusions, and then you take actions. If you're creating bad conclusions over and over again, you're probably going to hose yourself. But because there's a ladder, our brain creates a ladder, you have the ability to go back, walk yourself back that ladder, and correct yourself over a period of time through other observations, right? So this ladder and the various storages in our brain help us do that. And the knowledge community, over a period of time, I call it the ontology-verse, right? They see this knowledge representation and the lack of it in a typical data organization as a big challenge. And what has been done is, in the world of ontologies and semantics, the data has been fashioned, how data is modeled, how knowledge is captured is fashioned around how we organize data in the web. It's free-flowing, yet it's connected. Rather than capture data, we capture objects, real-world objects, right? We capture real-world relationships. And the idea is that by capturing relationships, by capturing what is happening, you are able to capture, you are able to do deductive reasoning, simply by the act of capturing that data and capturing the relationship. So there is a whole set of standards that were created to capture that information, as RDFs, owls, Sparkle, etc. You've probably heard of semantic graphs, property graphs, etc. Right? So these are typical ways people do knowledge engineering. I would say this is pretty niche, hasn't really succeeded in most organizations. There have been pockets of success in using these kind of technologies. But one of the big reasons why knowledge technologies haven't really taken off, couldn't take off, is the lack of skills, the esotericness of it all, and not really integrating with the mainstream, right? In terms of integrating with the SQL, with all the innovation that was going on with columnar databases, etc. Right? You can't really use it in seamlessly, but the concepts are very useful, right? Lately there's been a huge amount of upsurge, if you see, in the area of graph data science, graph deep learning, and these are areas that are really for those who have invested in creating connected data, creating graph databases, having their data truly represented as knowledge. They are being able to take advantage of advancements in graph deep learning, graph data science, etc. Right, in being able to connect the data further, create implicit connections as is knowledge, right? And along this, what I call the accidental semantic model, the advancements in in deep learning. So deep learning started as a way of automating the processes around how do I understand what's going on in unstructured data, starting with computer vision, image data, video data, being able to extract information, converting it into knowledge at scale was the primary driver for deep learning. And the methods actually then got transferred into NLP, into working with text data. And the reason why this transference happened was people realized that deep learning technologies, the convolutional neural networks, recurrent neural networks, were good when they processed that data. They created a semantic map, which means they are good at understanding meaning of the data or of the context of the entities that they were looking at, right? So those same things worked very well with unstructured data of any kind, right? So you had computer vision and audio. You had things like word embeddings, word2vec, etc. For NLP, there was CNN, RNNs. There is long-term, short-term memory for basically parsing data, creating understanding of sentences, context, etc. Right? And finally, just about 5 years back, you had transformers come alive, right? Which is the transformer architecture, all the transform models, of which the culmination that you see today in LLMs, right? There is transformers with attention, which was a way for basically attention is a mechanism through which a transformer is able to focus on a specific task out of basically rather than focus on an abstract meaning. It's able to give meaning to a task and is able to focus on very specific things that it wants to extract out of a text, right? And all of this culminated in LLMs, which helped. LLMs took it to the next level in terms of being able to do zero-shot learning, etc. Right. So there are three things that the transformer architecture brings, which is directly applicable to how we represent knowledge. Right. There is core knowledge embeddings, knowledge representation through embeddings, which is embeddings is a way of representing dense data, high-dimensional data. Right? And frankly, you can convert anything, even structured data, into high-dimensional data. Unstructured data, by definition, is high-dimensional data because the number of ways, number of attributes of a given text is huge. The larger the amount of text that you throw at a computer, just the cardinality of information is very high. Definitely true of video data, of image data, of text data. But what people realized was even with structured data, if you treat any structured data as just a table, right? If you convert it into text, for example, right, you can start seeing it the same way as a computer sees, unstructured data. So, for example, I could turn a table of information about, Sam, let's say, saying, Sam is the head of sales for Tiger Analytics. That's just captured in a table somewhere in Tiger Analytics database. But I start talking in English about it, you'll think of it as unstructured data, right? What he does, as part of his daily process, etc. I can turn it into unstructured data, and then represent it as what is called as a dense vector, right? Which is how deep learning models take their inputs, right? So deep learning models provide three things. One is knowledge representation, how you represent knowledge, how you do representational learning on that knowledge. And what that representational learning means is, if you're familiar with how machine learning operations work, machine learning engineers typically, they extract features, which is nothing but extract specific attributes, inputs that are that are important for the objective of a machine learning model, right? That contribute to the output objective. The representational learning basically represents the automated feature extraction. So in deep learning, one of the core benefits is that the feature extraction or the feature engineering becomes automated, right? The latent features that are actually useful for the end objective become automated, right? And lastly, transfer learning, which is extremely important, which is what you see as the biggest upside of an LLM, is being able to do zero-shot learning, few-shot learning, etc. Right? And that's largely driven by how deep learning technologies and architectures are created. They are fundamentally created with a few pre-trained objectives, which can be generalized to a large number of tasks, so that you can then fine-tune to very specific tasks. So what we see in language models is they have been fine-tuned towards, they've been pre-trained towards generating new text. But they've also been pre-trained towards a whole lot of other tasks, like translating languages, generating code. They've also been, they've been pre-trained towards classifying text for classification tasks, etc. Right? So you can basically use these very general tasks to fine-tune towards whatever objective that you have. Right? There are several instances that we have seen where deep learning and transformer architecture specifically are being used in classical machine learning areas. Right? Today, the top performing model for forecasting is not a classical ML model anymore. It is a deep learning model. Right? Same thing with anomaly detection. Right? Deep learning models are the state of the art models in those areas. These were typical classical models for structured data that have been appended by deep learning models. Right? So the same thing that is being used for unstructured data today is being used with structured data for structured data tasks like forecasting, anomaly detection, etc. It's also being used for recommendation engines. The couple of areas that we are working on right now with the deep learning models is in the area of synthetic data generation, right? Where we not just synthetic data generation for video training and for image training, but also for typical, typical tasks for structured data. So taking tabular data and being able to, in a privacy differential way, being able to create synthetic data, right? When you there's a lot of places where third-party data is brought in by just web scraping the data. Being able to bring that in at scale by developing tabular data understanding, right? That's something that you can do with deep learning models very effectively, and not just bring that data in, but understand what it is, being able to assign it, its metadata meaning. So those are some of the core knowledge models. They are more generic knowledge models that are out there that are different from your typical LLMs, right? These are tools in your hand that you could use towards any of the tasks. So where are we headed in a post-OpenAI world, right? Somebody said recently, age of giant AI models is already over. It barely started. Can you guess who said that? That was Sam Altman himself. So he said that back about 3 months back. Why did he say that? Well, as per the first of all, as per the OpenAI team itself, their notes, giving more data, more parameters to a large language model is hitting its limits, as in the amount of additional benefits that you're getting in terms of more performance, less hallucination, etc., is becoming lesser and lesser. So even bigger models are not going to give you better, better models, but it's not giving you a better product. But what it does give you is a higher cost of development and a higher cost to the environment. So as you can see, basically the number of parameters as they scale, the environmental cost and the computational cost is this is a logarithmic scale, so it is actually exponentially increasing, right? So what is the future really? If you see just in the past few months what's happening, the initial fervor around using ChatGPT, primarily as a source of creating LLM-based applications, is dying down a little bit. The majority of the use of LLMs is being done by training smaller, distilled deep learning models. Some of them are LLMs, some of them are not even LLMs, right? So not just GPT, but there are llamas, etc., open source llamas, etc., that are being used and being trained for very specific tasks. So Gorilla, for example, was released by Microsoft Research, which basically which can be used. You can give it English language instructions to go and do a certain task, which it translates into API calls, right? Databricks released something called Lakehouse IQ. And what it does is, instead of you all know by now, ChatGPT is pretty good at firing SQL instructions, right? If you give it a text command, it can convert that into SQL and go against a database, right? But ChatGPT really doesn't understand your organization's language, right? So for example, ChatGPT doesn't understand if I want to know. I'm a Databricks user, and Databricks usage unit is called DBU, right? If I ask, how many DBUs am I using for Databricks, it will not know what DBUs are, so it will not be able to answer that question, right? So if I gave it context, it will know what to do with that, right? So ChatGPT doesn't know, or any given LLM doesn't know your organization's context, right? one of the most useful things you could do is create a model of your organization's context. And what does that mean? That means all the metadata you have about your data, all the organizational hierarchies that you have, all the operating procedures that you have. These are useful organization context. If you provide that to an LLM, it will be far more useful and far more computationally less intensive for the interactions that you have with an LLM. Right. So Lakehouse IQ is a pretty cool implementation from Databricks, which does exactly that, which works on your organization's and enterprise data assets to give as context to a lightweight LLM. Right. Then there is there's knowledge models around, specifically around biomedical information. So, for example, PubMed-BERT, which is a knowledge model built on top of BERT for detecting protein-protein interactions, it outperforms GPT-4 significantly in that particular area. It has been specifically trained with a knowledge context around biomedical information. So and it's much more lightweight, right? Which means less cost to you, more scalable usage of it, etc. as well. So what's the future really? Is it us creating this one giant oracle that knows everything? Probably not. The future is likely that you create very specific, strategic information assets, knowledge models that that you can orchestrate using agent architectures and create intelligent applications. Right? At least in the near future, that's what I think many companies and platforms are envisioning that. I was in the Databricks conference recently. Ali Godse himself said that the way they see it, companies want to create their own IP, right? And they want to create their own moats, and that's how they do it, right? So how do you really go about creating a knowledge model, right? What you're trying to create what do you have as your company's knowledge? This is, if you look at the screen, it is a resource ontology, right? You have 4 kinds of resources in an organization. You have your various people in the organization, your employees, your customers, your partners. You have the products that you sell. You have your business processes, and then you have knowledge resources, right? Your knowledge resources could be the patents, standards, papers, R&D work that you do, the reports that you generate, share with others, etc. So these are all the things that you could assimilate, one or all of them, into your own company's knowledge model, right? If you've been following Bloomberg, as about 3 months back, released something called Bloomberg GPT. It was essentially this. It was a subset of this ontology that they encoded into Bloomberg's own GPT model, right? So it's a very powerful concept. If you can do this, take your entire R&D organization's data, your patents, your standard operating procedures, how you run a plant, and put some governance on how you update it also, of course, and feed it, not just have data, but this knowledge alongside your data for context. It becomes far more powerful than creating models, ML models, which work without the context of processes and people, right? So if you think about it, knowledge is about connecting information, connecting data, and creating wisdom out of it, right? So there are direct connections for which which we largely know how to deal with. Sometimes efficiently, sometimes not so much. But for example, we know if where a customer order should be shipped to, what shipping address it is, etc. That's a bunch of information we can easily tie together, right? But then there is indirect connections, right? What I as a manufacturer want to sell versus what my retail partners sell may be categorized differently, but it may be the same thing, right? Being able to find connections in that kind of a data, where it's the same data but represented differently, right? Or finding somewhat indirect links in data in that so there was a spike in COVID cases, and it was identified as a root cause, in shipments on a certain time, right? So there are links to a particular situation that happened at a particular time for a particular event, right? There is that kind of information that can be captured, right? And finally, there is the most valuable thing is when you can create indirect links, based on prediction of those links. So, for example, if you are in a situation where you're trying to find a supplier in your supply chain, your current supplier is disrupted. You're trying to find a supplier who is like that current supplier, who has all the operating equipment which is similar to that supplier, and you can create an alternate, a backup to your supply chain, right? If you knew information about that supplier, right? Knowing what is a supplier who could work instead of your primary supplier is, it's not a simple task. You don't just need information. You need to be able to do a fairly high level of approximation based on a whole lot of parameters, right, to come to that. So that's another kind of a way a knowledge model can help us assimilate that kind of information better than how we do it with today with data, relational data, how we capture it today. Right. So where are we as Tiger working on knowledge models? There's a bunch of areas. There's one that I'm going to walk you through on the how we create customer knowledge models. This is something that we have been working on for last year or so, even when LLMs were not released. That concept of meta learning, etc., was there. So we started working on that, and I'll walk you through that. But then there is knowledge models around suppliers, vendors, products, etc., right? These are very core, useful concepts that are needed for any large CPG company or a manufacturing company who does not directly sell to their customers, who depend on intermediaries, distributors, etc., and they need to constantly marry external data with internal data, right? They're creating signatures of data, creating knowledge models around what a vendor is, can significantly cut down and scale down the operation around marrying external data and internal data, which today is, for a large-sized company, it can be a fairly large-sized operation, right? Thirdly, there is, I'll skip the metadata automation piece because there are several such examples around basically building knowledge models around enterprise metadata. One I mentioned around what Databricks has done, but around R&D, right? This is alongside contracts and legal. R&D is a great area to build knowledge models around, right? Where your core data asset, how your raw materials, their fundamental composition can relate all the way from from their core characteristics that you are researching in during R&D, all the way to sales, marketing, etc. What's the impact all the way to your sales, and how you can create the right kind of messaging, right? Those are things that can be really helped by a knowledge model around that. And then finally around supply chain itself, where a consolidation, breaking the silos and building a comprehensive knowledge models that can go across multiple silos in a supply chain. That's another good area to look at, right? So here's a picture of what we call as a customer, or what we are creating as a customer knowledge model. In the middle, if you see, you'll see the dynamic customer understanding engine, which is nothing but a knowledge model. And what it is really, you can think of it as a customer GPT for a given customer, for a given enterprise. And what we have done is, this particular one actually represents a grocery customer. So it captures behavior data of a customer. By behavior data, you mean how they are interacting with the products on a website, right? How they interact with the grocery basket on a website, as well as on an offline channel. So we capture that behavior data. We treat it just like any other unstructured data. We actually embed it, take that entire session of information, turn that into a time series, and turn it into a dense vector representation, create an embedding out of it, with the goal of being able to capture what is the next intent of this customer going to be, based on the most recent activity that the person has done, right? So if they have put in, for example, milk in their basket, what is the most likely next action that they're going to do, right? What's the next likely action they're going to do? And based on that, what can I do as that grocery retailer to make that experience better for the customer, right? So knowing, pre-training this knowledge model with that in mind, being able to service that customer at the moment of truth becomes the foundational knowledge model. I can now take that fundamental knowledge model and train it on multiple other tasks. So we've been able to train that same model to be able to do predictions around whether this customer is going to make a call to our call center or not, right? What is the likelihood that they're going to do that? That same model will also give us information on what is the CLTV going to be. Is this likely going to be a churn customer or not, right? So the foundation being the same guarantees us that there is a level of consistency across all these models that we are building, as opposed to what we were doing earlier, which is having 10 different models, ML models, that are not connected to each other in any way, right? Having that foundational base of customer behavior sessions, embeddings, product embeddings, and interactive embeddings, near real-time embeddings, gives us that ability to say, hey, we can predict something at a customer level, which is aligned to our company strategy at all times, because that's our pre-training objective. That brings a level of consistency across the entire value chain. Right. So this is, what we do. This picture kind of represents it. So what we do is we take all the offline purchases, returns, product information, the service interactions of a customer. We take all the clickstream data, create a temporal network around it, and then we create these customer, product, and time-based embeddings, and that becomes our core representation, based on which we then create these fine-tuned objectives, right? And we basically use a very lightweight transformer architecture to create these knowledge foundational models, right? How are we doing on time? I'm sorry, I can't see the time. 5 minutes? I'll just open it up for questions if you have any. Sure.
Okay, so you were saying that by producing smaller models,
Yeah.
We reduce the cost to produce them as well as the cost to maintain them. But what if I have several small models that I need to interact? Is there a way to do that? Do I have to produce one single model for all of those, or can I use a concept like topic maps to interact with multiple models?
No, thanks for that question. So there are two objectives that you want to achieve with the smaller models. In general, the idea is that the smaller models are not just cost effective; they're also likely to they're also likely to hallucinate less because you are training them with very specific objectives, right? So they are good at what they do. And the idea is that if you're familiar with agent-based architectures, agents are good at being trained to take instructions and learn which model to invoke for what task, right? So there's an agent which is good at understanding instructions, and then there are models which are very good at doing very specific tasks with a certain level of safety, a certain level of reliability, right, that you have tested it for, as opposed to one model that is fairly difficult to test on multiple different objectives, right? So does that answer your question? All right.
Vishal, first of all, fantastic presentation. I mean, I just love the way you've laid out the whole very complex, very broad topic. Would you say that this is tuned more for like these learnings and estimations and approximations versus kind of fact-based reporting, like would I close my financial books for my company using a large language model? Or, I mean, what's, because we're talking about structuring or unstructuring structured data, really. And
right. Yeah, so when it comes to reporting descriptive, use of analytics, even today, you really don't rely on a machine learning model, right, or wisdom out of it. Where knowledge models help over there is, for example, or large language models would help over there is summarizing what you are seeing in those reports, right? And where knowledge model can assist, a general summarization engine like a ChatGPT is providing more context, right? Context that is relevant to your industry. So, if you are summarizing something, that is fairly standard in terms of a financial report, I think you'll have a financial, reporting model, XBRL or something that's very conversant with a financial reporting, standard. That can really help with summarization of that report in a much more reliable way than using a generic, a large language model.
So Vishal, we've run out of time at this point, but I'm sure if others have questions for you, you've got contact information that you can.
Yep.
Yeah, stop by your booth, right? Absolutely, not hard.
All right.
Vishal, thank you very much.
Thank you.